Yes, welcome to this webinar, Meeting Future Challenges with Advanced Cooling Technologies. I am Venessa Moffat and I'm representing the Data Center Alliance. I am delighted to be joined by a panel of esteemed experts today who are specialists in this field. And I think it's well recognised that we find ourselves in unprecedented times with more demand than ever before. So today we'll be exploring the practicalities, maybe even challenges and opportunities of delivering against that demand. We will be leaving some time at the end for questions, so please feel free to add questions into the chat. That does come up, doesn't it? Yeah. So I'd like to start with asking all the panelists a question, but I'm going to ask you as well to introduce yourselves first, then answer the question. So it's a two-part question. And the question is, what is the biggest challenge in the sector right now with regard to cooling? And Ramki, would you mind if I started with you first?
Yeah, sorry. Thanks, Vanessa. Hi, everybody. I'm Ramki. I look after the sales for Europe for nVent and our data solutions division. So to answer your question, Vanessa, I think the biggest challenge for us is basically to bridge the gap between the customer expectations and the current capability of the cooling technology. And also to provide solutions that actually work in the real world and within the customer's time frame and commercial framework. So that's, I think, which is our biggest challenge today.
Excellent. Okay, thank you very much. And moving on to Markus, please.
Hey, welcome everyone. So my name is Markus Gerber. I'm based out of Germany. I'm working as a senior business development manager on the sector, what we call, or the business unit we call data solution, and handling this quite some years now, several European projects. I think, let's come back to your question. Mm-hmm. I would say, being in that market, yes, more than 15 years and watching several cooling technologies, I think there was always a shift, but the challenge right now is the speed. So the pace the market requires this change was never as quick in the past. So I think that's the main challenge we have to overcome at that point.
Brilliant. Thank you very much. And Daniel, next.
Hello, everyone. Thrilled to be here today. Thanks, Ness, for the intro to this. Daniel Burczyk, working for one of the partners at DBK Consulting. Excited to be here today and discuss this sort of thing. Obviously, there's a lot of challenges there. May that be scale, deployment, speed to market. But I'd like to put a focus on a topic that's obviously close to all of us, which is making sure that whilst all this deployment and the demand is surging in its current form, that we all keep an eye on all the sustainability matrices that we have, and making sure that what is being built is not just quickly deployed, but also ticks the boxes of sustainability, and with an eye on that these facilities will be running for a fair amount of time and tick all these boxes. So I do find that's one of the key aspects, whilst we all obviously want to build in the meantime.
Brilliant, thank you. And last but not least, Stefan.
Hello. Thanks a lot for the opportunity to speak and to share my insights. My name is Stefan Djuranec. I'm principal engineer for cooling at nVent, and deeply involved into development of the current and next gen cooling technologies at our company. To add on topics which are already been a little bit mentioned, but from my point of view, the biggest challenge is currently that we have sort of two contradicting trends. One is the energy densities for racks and for compute is currently almost exploding. Now Moore's law really kicks in into the market, and on the other hand, Also what Dan brought in, like sustainability, but I would also say like efficiency of cooling technologies, the request for being more efficient, more sustainable, is basically contradicting or going into the opposite direction, makes us want to reduce the performance densities. And this is currently really a challenge to bring those two together, so and basically fit the requirements. First of all, the energy density, and second, being efficient. This is challenging.
Yeah, really good answers, and 4 very big themes actually within the cooling sector. So I think bridging the gap between what's real and what can actually be done, and the speed to market, Markus, absolutely, and then sustainability is always got to be front and center, and the contradicting trends. It's really tough times at the moment. So I think one of the things that we're seeing is, amongst all of these big challenges is rack densities is a big factor, wouldn't you think? So that we're actually seeing higher rack densities now. I think for quite a few years, it was 8 kilowatts a rack, and now we're seeing Digital Realty posting 70 kilowatts a rack, and CyrusOne posting 200 kilowatts a rack. So Markus, what are you seeing, and how do you think we should approach this? You mentioned density into relation to power. Would you mind explaining that one, please?
Yes. So yeah, you're completely right. I think when we first started on new cooling technologies, we were like all expecting this to ramp up quicker, but then the market stagnates kind of at the 5 to 6 kilowatt benchmark density per rack. What we see now is all the people coming in and say, hey, we want 70, we want 200, we want whatever. I'm just thinking, take a step back, because it's not just about taking the heat out. It's also some other factors then coming up, which is how you get the power in. And I always like to compare this with the traditional, the rack mount PDUs kind of, where I say, okay, very long time we worked on single phase. Then we saw a shift to a 3-phase 32 amp PDU, which is kind of common in data centers over the last years. And this only provides you like a 22 kVA into available power. Mm-hmm. And now people are talking that high densities, they need to rethink. Either they are putting a lot of these PDUs in one rack, or they go up to 63 amp, that's what we see or what we follow, or even 100, 125 amp 3-phase, just to get the power in. Mm-hmm. And that's always the second question, or basically when people come, that's then the starting point. And you could even take it from power away to the rack, because if you have, for example, and we will touch base on cooling and infrastructure, you might consider a deeper rack, you might consider a higher load in the rack, you might consider a lot of points that makes an impact on the infrastructure. So, and I think that's fairly long answer to a short question.
Oh no, it's a good answer, because some of the racks are taller and they can't get in lifts, and some of them are too heavy for the raised floors, etc. So yeah, we see that quite a lot. Ramki, what are you seeing? Are you seeing some changes in the demands from customers or requirements from customers?
Yeah, absolutely, Vanessa. I think what we are seeing is that customers, are asking us a lot of information, a lot of engineering support, very early in the design phase. And we have moved on from, I think, just being like a kind of vendor, but we need to start where we are fitting in is that we have been asked to provide a lot of calculations, to the customer to help them design a solution. And to Markus's point, I think we also need to understand that the solution just does not need to be does not need to work on paper, but also on site, right? We're talking about serviceability, etc., and all those things, redundancy. These are all typical parameters for any data center. But I think that's where we are being challenged a bit, that it's moving the design from paper to actual practical site experiences. And I think that's where we are being asked by customers, and we are having to involve people like Stefan, people like Markus very early in our discussions into the sales cycle. So that's why we have been asked by the customers.
Thank you. And Daniel, are you seeing the same things? You there?
Apologies. Yeah, I pushed the wrong button. No, very, very, very good points. Ultimately, zooming out on all of this is we're obviously trying to solve, well, the not really an issue, but what is solved is compute. Now, obviously these higher rack densities, and that's ultimately the product. So, you know, within reason. Now there's obviously multiple layers for different services providers on what they do, how dense they need these chips to be in order to do that. And there's obviously a trend to higher densities, and that opens up a lot of opportunities as well. You know, just from a PDU perspective, you know, there's new market trends, there's people, you know, developing new products accordingly. And it is a lot of opportunity for the market as well to showcase that we can not just legislate here in Europe, but we can also be agile and develop new things. Now, how much of that, you know, high density stuff is directly translating, whilst we also see all the, you know, the German Energy Efficiency Directive and other things playing a part in all of this, is a tricky one to put your finger on. But I mean, ultimately, we're all trying to be quick in solving these problems. But there's also the other element to all of this, that we obviously not just building these facilities for today, as Markus rightly pointed out. I mean, I would have thought as well that these densities come up much sooner. We're there now. But we're building facilities that obviously need to last for the next 10 to 15 years. And with that in mind, that influences design to some degree as well. So yeah, it's a complex challenge to be solved, not just from a power, but from a cooling perspective. And yeah, I think we're all up for that challenge. So yes, the short answer to that is yeah, we see that as well. All the time. The variety seems to be much broader now. There seems to be more business cases for people that do want to deploy AI very specifically with a very specific business case and a specific solution. But there's also the other end of the spectrum when it comes to storage and other things that, you know, not to underestimate. That's a huge market share as well. It's not just all AI all the time, I suppose.
No, that's true. That's true. And data centers are a system of systems. But from what both you and Ramki are saying, that it seems to be getting more complex, and the designs seem to be getting more complex and maybe a bit more flexible within their full remit. But Stefan, you were also talking about lots of different factors involved, and there's lots of different ways of optimizing. Did you want to elaborate on that maybe a bit?
Yeah, what we basically the first factor which kicked in for a couple of years now is basically the seek for better efficiency, where we saw like customers wanting to raise the equipment temperatures, especially with liquid cooled or data centers, or at least with CRO units and radio coolers, intercoolers, that they are trying to go up with higher temperatures, which basically brought in like, okay, is the CRO unit the perfect or still the thing to go? How can we optimize it? How can we what's the path to going into more efficiency? And this is where we also see sort of a transition more to localized cooling. So not cooling basically a very big room with lots of air, but trying to distribute it or to separate it into smaller pockets, which are easier to control, easier to cool, and basically satisfy more the localized needs. Because and because of the questions, okay, I have this big data hall, I have 5 kilowatts per rack equipment, but now I want to bring in some compute or AI into it. How do I assist? Do I need to redo my complete infrastructure, or can I do localized things, bring in radio coolers, for example, to only cool the AI or the high density liquid cooling into the equipment which really needs it, and leave the remaining equipment what it is. And I believe from that point of view, there have all sorts of versions evolved, or different cooling topologies, different cooling techniques as well, and also depending on what market we go in, and or what the end user requirements are. And currently, it's there are so many configurations, combinations of different cooling technologies involved. And the other trend is currently basically also the drive to liquid cooling. One of them is definitely increasing the efficiency. Liquid cooling is so much more efficient than air cooling, but also the real or the pure necessity to introduce it from technical point of view. For example, if you are planning with a 120 kilowatt rack, currently there's almost no way around direct to chip liquid cooling if you are talking those high heat densities. And I would say also there's a change required in the mind of thinking. When we built data centers 20 years ago, there was like air cooling, temperatures 22 supply, 35 return. Now equipment, even air cooled equipment has got way more efficient. And I believe also many operators still need to make that transition into, okay, I don't need to overflood the data center with air. I can make it more efficient.
It feels like they're two worlds apart, really, doesn't it? So the new HPC stuff coming in with hybrid cooling, and then like the good old days of 4 kilowatts a rack air cooled feels so different apart, and we're racing towards it so quickly. But I think there's probably quite a lot of hybrid environments or hybrid designs going on. I think, Dan, are you seeing much requirement for that? Because what I imagine is all of these older sites, they need to have lots of liquid cooling or direct liquid cooling coming in order to meet whatever demand they've got coming in that way. If the site's not purpose built for AI, obviously. So how's the hybrid demand going?
Yeah, very good point, and a few points that I'd like to pick up from Stefan there as well, for sure. Hybrid there's obviously that element, and I mean one of the main reasons why people look at hybrid systems because it gives them flexibility as well. I mean, some of these design principles around hybrid systems, when you look at the detailed sizing of all the equipment, you can be far more flexible later down the line, depending what the distribution is between the actual perimeter cooling as well as the directed chip and other. There's obviously some tests and people looking at that, what that is for specific chips, what's the K value of some of these chassis, and it within reason there's quite a lot of R&D going on there. So I'm not sure there's a silver bullet either. Obviously, liquid cooling, there is, you don't get away from hybrid today for sure within reason. The efficiency gains that we, to be quite frank, obviously the liquid cooling is a big term, and the benefits that we all would have expected to come from liquid cooling, to be honest, they haven't really materialized to a large extent as much as we probably would have liked. I mean, flexibility is obviously one of these systems, but as Stefan pointed out there, obviously, the densities that we see today and the technologies that solve these densities are they're quite vast in terms of who does what products are there. The key aspect ultimately is to develop an R&D products and systems that continuously solve these problems. And with Moore's law, and looking at the latest trends, Moore's law is looking like as if it's going to be outpaced very soon, actually. And then we've got an even bigger challenge on our hands. So I know it's fair enough. The hybrid systems are an exciting thing for all of us. It means we've got some engineering challenges, and we can play around with things and make sure that they largely tick all the boxes. May they be planning, efficiency, may there be sustainability, and else. Hope that sort of roughly answers the question.
Yeah, no, absolutely. It's a big question, isn't it, really? Because there's so many different factors to it. So from a hybrid cooling point of view, and the fact that most data centers have got various, different use cases and probably different business cases, depending on the use of the data center, but also depending on what they want to do with an existing site. There's probably different answers for every single question right now. Markus, are you seeing a lot of innovation in the market from that point of view?
Yes, so I think let's get a step back. So when we talk hybrid systems, I just want to ensure that we talk all the same thing. So I think a hybrid system would be a liquid cooled and air cooled system, and I think yes, there is a lot of innovation going on in that space, and I always like to take to look at it as a design journey, kind of, because what happens at the beginning, at the very early days when I started, we talked about rack-based cooling with fans. So glass doors, fans on top, removing heat. And then suddenly this moves to a room-based cooling, having a central unit, a raised floor. And with the latest developments, we move from the room-based to an in-row cooling devices, moving to a rear door to a rack-based cooling device. And now we are moving into the server itself, just getting closer to the heat. And this is mainly the steps we take. And I don't want to touch immersion. I think we will come back to that, but this would be, yes, it's not the hybrid. So staying with hybrid systems, this is another advantage or driving this trend, or driving this new ways of cooling, is you can relate it to your facility temperatures. Yes. So when you move closer to the heat, then you can optimize your temperatures. You can increase your liquid temperatures, which allows you to be more efficient. And we had this also as a topic already. Daniel mentioned it. This helps people to increase the energy efficiency of the design of operating points. And at the same time, when you increase your inlet temperatures, it offers you, and that's also part of the energy efficiency law, it offers you the ability to reuse the heat. And I think that's another consideration we have to take with looking at these innovations. And this was a long answer, but short answer, a lot of innovation going on, a lot of new developments, and it's really, yes, challenging and interesting to keep pace.
Yeah, absolutely. And I think with the running things at slightly higher temperatures, we're going to be able to reuse that waste heat a lot more readily and find clients for it as well, because with the traditional air-cooled data centers, the heat, it wasn't high enough and you can't transport it a few miles away. It loses the heat, yes. It goes away.
And every temperature on the heat pump helps. That's another thing. I'm not saying you can immediately reuse it, but any temperature, higher temperature on the heat pump helps to save energy.
Yeah, absolutely.
Maybe to add into this, I see let's tell it hybridization of cooling is basically the path forward, and just because you will need for some applications at least to bring in the liquid to the rack, because some compute gear will require it, definitely. Some it's a nice to have to get more optimized. But when you're bringing the liquid already to the rack, I mean, then you are planning with something, a hybrid, and then it's basically the best way. Okay, what is your best hybrid solution to find? There are various factors to take into account. The rear cooler is probably the most efficient one, because it doesn't require aisle containment. It doesn't require a hot aisle. It doesn't require people to be able to work in that hot aisle and keeping the temperatures low. But Probably there are also other factors like redundancy. How do we establish redundancy with rear-door cooling, and so on. But I would say, since you're already going with the liquid to the rack, the rear-door cooler is, for example, a good solution. And then you have the localized cooling method in there, which gets you the efficiency and the freedom of planning. Okay, if you're, for example, a co-locator, you never know what IT gear the customer will bring in, and then you're prepared for both. And then you need to plan with both, like full-scale liquid cooling, but it can also be full-scale air cooling. And this is sort of, you're installing twice the heat capacity or heat removal capacity you actually need.
Yeah, and it kind of comes back to Ramki's point earlier on about flexibility of infrastructure. And potentially, what about IT and facilities having to work a bit more closer together? What do you think? Anyone? No one's going to answer that one.
No, I think
let's
let Daniel go first. Go first.
Go on then.
We all have to talk an awful lot more these days. I mean, again, walking backwards, like when I started off, which isn't actually that long ago, maybe less than a decade, it was pretty clear on what the roles are of everyone, on what they had to play. We sat on the perimeter, we did what we did. And we never really interfaced with the IT at all. Today, we'll travel to the NVIDIA conference in the US, and we talk with all the chip suppliers, and that's quite an exciting journey for all of us involved, because it brings it couples the actual engineering much closer with the ultimate product end, which is the compute and how we solve the interconnected piece. It brings and it is pretty exciting for all of us, I'd say. We learn a little bit more. It opens up a lot more collaboration, and there's new solutions that come from that. So one thing I did want to pick up on as well, with that in mind, is obviously there's no silver bullet for any of this stuff. The only thing we all want is progress. For sure. And if you'd asked me like 4 or 5 years ago, I would have said that at this time we probably couldn't gotten rid of mechanical cooling to a large degree, and we did make some really good progress. And I suppose the element of rear doors and everything has its pros and cons. It does feel a little bit like a step back to then bridge the gap thereafter. Obviously, it does have its use cases and it solves one very, very important issue, which is higher densities. So whoever sells high density racks, that's probably within reason one of the more reliable and known technology to solve that. But we don't have to kid ourselves with that. There is implications to that. There is additional plates. There's losses here or there. So again, it's not a silver bullet, but maybe it's the right way to see progress and get to a point where eventually we can all get rid of mechanical cooling aspects and make these places even more efficient.
And maybe if I can just to add one point, I think you're completely right that the rear door might bridge a gap that we have. I think the best option or is getting rid of air, moving to liquid at one point, which I don't see. Fair enough, I don't see right now. So therefore, for me, the rear door is not just closing a gap. If we talk 100 kilowatt per rack, 20% will still remain on air. So cooling 20 kilowatt the rack with air, I would question if a traditional room-based layout is capable to do this. So some installations will require rack-based solutions combined with direct-to-chip solutions. And being fair, you mentioned and I share the same view that the 10-15 years that the infrastructure have to last, I would definitely say that's still in at least the 10 years is still in line for those combined technologies. And And if I could address one point, which is, and you mentioned it really, really good, is I always say infrastructure and compute merge. And that's exactly what you described. We talk to different people because we have to, and that's important. That's really, really important. And yeah, maybe we get better there, because what we sometimes see is, here is the new compute, and now operate. So and that's definitely a challenge. If I come back to the very beginning of the conversation.
Maybe to add into that, I believe definitely in future infrastructure and compute will need to talk, because just to say, with air it was quite easy. Like, okay, air is everywhere more or less the same, besides filtering and humidity control, but this is like easy things to cope. And then air is air. And now with liquid cooling going into these topics, you know, like water is not equal to water. There are numerous additives, there are numerous chemical properties and so on, that the server requirements, on the other hand, different operating temperatures, those need to get together at some point, and this is most likely currently the server. How do those operate together on the liquid side? I believe this is one of the current critical points where they definitely need to co-work. Or even, I mean, if the server say, hey, the IT guy say, oh, I want to bring in liquid cooling, and the facility guy tell, well, but I have no liquid in the data center, so what do we do? Is there a way to still go with liquid, with liquid to air, IT release the heat somehow from the liquid into the air, or do we want to bring in new liquid cooling and so on? There's all sorts of things to address. Yes.
Yeah, extra complexities. And like Ramki, you were mentioning earlier that you'd have to bring in people like Stefan earlier into the design phase because of these complexities. Are you talking more to more IT people nowadays, do you think?
Completely second most of the opinions here. I mean, the line between IT and facilities is certainly getting blurred as we go along our journey. And you're absolutely, I mean, customers, I think from our perspective, they're looking for a partner, more than a vendor, somebody who's just not here to sell a product, but somebody who works through them through the life cycle of their data center project, so to speak. And as it evolves, you know, we need to collaborate, we need to talk to them, give them feedback, help them design, as I said, a solution, not just something that we have to sell. And I think that's where the industry is going, that, you know, if you want to be in this space, then you need to be flexible. This point has been brought on several times, but also open to change. Technology is continuously evolving. We have to move, and we have to be quick. So there's pretty much everything, whatever we said, is kind of coming back to the earlier point. So flexibility, speed, adaptability, these are the buzzwords really, if you want to be active in this market.
Absolutely. Okay, so I think we've got about 5 minutes before we can take some questions. So I'd just like to ask about standardization, regulation, guidelines. I don't think we've got too much. Stefan, what do you think? How's ASHRAE doing?
Well, I'm not super involved into ASHRAE. Our colleagues from our company are in there. I would say there is so like two trends from ASHRAE point of view. There are standards for liquid cooling, but those are more on the facility side, on facility level. They are giving some guidelines or recommendations to when it goes into the IT, but still it's not a lot standardized, like okay, how do servers connect to the CDU, how do those connect to the manifold, how's the distribution, what are materials, chemicals, and so on. This is still not etched in stone, and there is a lot of movement there. I would say the other organization who's trying to bring in more clarity into this is the OCP, the Open Compute Project, where we are also involved into and collaborating with them to move this step forward with all of its challenges and pros and cons. but I would say those are the currently two main organizations which are looking into it, developing and evolving the technology, or defining the interfaces, the requirements on that side.
Thank you. And Dan, you had some points on this as well, I think.
Yeah, this is really good. It's always a very, very interesting point, legislation. The interesting one here is that obviously when you look at governmental policy, ultimately legislation, to a large extent is very reactive. We all want standardization, but you can argue that the majority of colo data center provider hyperscalers, they act so fast in comparison to governmental policy that they set standards that are probably superior at this stage, and it's not easy for legislation to follow. I mean, legislation is there to set the boundaries. It does, if you look at the European growth compared to others, the US, where legislation, these sort of things aren't legislated even remotely close as we do. Their growth pattern on this sort of thing looks far superior. Is that the right thing? Is that the wrong thing? It's probably debatable, but it'd be good. I mean, it's guidance after all. I think there is legislation needed. It's obviously lagging behind in loads of areas. I'd say that's reasonably normal. And I think things will within reason run its course, and we'd hope that the companies, the right policies are being implemented internally. And when it comes to the actual legislation around very specific points like PFAS and so on, that they're obviously very, very on point and what has to be done on that front. And then the consumer will largely drive on where we're going to move as far as liquid cooled and densities are concerned. The only real key ones that we all have on our radar is that the progress that we're going to make is going to be building these facilities more efficient. Everyone has the on renewable energies and sustainable goals. They're a very important point. Carbon, embedded carbon. I mean, they're all part of the sales process for compute these days. There's boxes to be ticked, and if you want to stand out in the market, people endeavor and companies endeavor to follow those. So it's largely positive. And then there was a piece from Emmanuel Macron recently. I don't know if anyone saw that, and where he was even questioning the amount of legislation. So maybe within reason, controversial or not, we need to adopt a more worldview on that. Some things just need to run its course, and we'll need to see where they end up.
I would maybe to just add in, sorry. Daniel brought in an email a very good point. I mean, if we think at Moore's law, okay, compute density is increasing every second year. So if you go into a traditional way of data center planning and development, like we're planning for 10, maybe 15 years of operation, this is like 7 cycles of Moore's law. So 2 to the power 7 is like 128. So if we plan for the equipment, which will need to last for the next 15 years, we will have 128 more or higher compute integration of the equipment. And this is basically a super fast and very high speed development. And I believe the industry, the key to solve those challenges will be the industry collaborating closer together. Like we told infrastructure and compute to work together, the big consumers and the big manufacturers, really defining what's the next step and evolving and keeping this in progress.
Well, Markus, very briefly.
Yeah, we'll keep it short. I think we talked legislation. I think one simple example is we are on a journey. So this is more about standardizing on the compute side. When you consider, again, a PDU, you have so many country-specific outlets. So in the past, we had Schuko, UTE, British Standard, whatever. Everyone consolidated on IEC, C19, C13. And we have a similar situation right now because you have to connect the compute to a manifold to support it. And it's not standardized. It's all over the place, different connectors. And then just taking this as an example, saying, yes, let's continue the journey. Let's drive standardization. And yes, I think we get there. Brilliant.
Thank you. So I think what we'll do now is we'll have one question and then a very, very quick summing up afterwards. Kaylee, is it all right if I just choose one?
Yes, I was going to say, I don't know if you want to have a quick, we've had quite a few flurry come in at the last minute. So if you want to take a couple, we're okay to go a couple of minutes over. So if you want to choose a couple, thank you.
Right, so the first one I'll choose then, these are all anonymous, by the way. As liquid cooling adoption grows, what are some common scalability challenges data centers face and how are vendors working to solve them?
So maybe to add in, so we are basically working very closely to the manufacturers, and yeah, for example, with all the AMDs and the Intels and I don't know, the collocators and so on, to align this and see, okay, what's the next step? Where are we going? I believe the communication there is key, and keeping close contact to all the stakeholders, to say so, finding out what will be the needs, where will it go, from challenges to scalability. Yeah, maybe if someone other wants to comment on that.
Yeah, I'll chip in with a very minor point, again, maybe mildly controversial, but it's obviously one interesting point is that we're now looking at, and maybe nVent is a very, it stands out there as well, is that we have a marketplace which is very largely saturated by air type technologies. You can look at car industry as well, where the combustion engine was a very well established piece of kit with large manufacturing capacity and all of that. And now we have the commercial challenge to basically have another type of engineering coming into this market from companies that, you know, within reason, some of them, you know, they're you know, below 10 million arguably, and they're coming into market with, let's say, a liquid cooled solution in some instances. And there's quite a lot of them. To go into market looking at 100, 200, 300 megawatt data center. So one of the big challenges for all of this is not just the engineering side, it's also the commercial viability on large scale production. And obviously established large scale manufacturers have that available. That's not always where all the innovation is coming from. You know, there's a large innovation piece from the other side, but they have the commercial challenge and getting into this marketplace, whilst, you know, these projects are just, to say a better word, humongous. And that does pose its challenges. It's like the fabs. I don't know if you guys are aware, but the TSMCs, the Micron of this world. If you want to build a fab facility these days to build semiconductors, you can start off by writing a 50 billion check, and below that you're not going to get anywhere. So it's maybe that's one of the challenges that I think is underestimated, that these projects are not so big that you do need reasonably deep pockets.
Brilliant, thank you for that, good insight. So I'll just round up by firstly saying thank you to you all for your amazing insights. But I think some of the themes are pretty clear, really. The complexity is definitely on the increase. And I definitely agree with the contradicting trends where we still have to focus on sustainability, regardless of the increased demand. And the speed that we're trying to work at is necessitating some holding patterns and some gaps to be bridged in technology, just like the rear door coolers, for example. So yeah, really interesting times, and let's see where it all goes. Thank you all very, very much.
Thank you, guys.
And I just want to say thank you so much to all of our panelists and to Venessa for very capably moderating what is, like you said, a really difficult topic at the moment with lots of conflicting issues. So thank you all so much for joining us today and sharing your insights.